This is an example to show how to use vectors to add together um, displacement vectors when somebody moves from one place to another. In this particular example, I'm given cardinal directions, which makes a vector problem much easier to do. The first thing I want to do is define what north, south, east, and west are on my paper. I do that by drawing a simple compass rose so that anybody knows that what I draw, they know exactly what the directions are. The second thing I need to do is define a drawing scale that I'm going to use. The drawing scale should always be appropriate so that the vectors that you draw are long enough to be accurate and precise, but not so long that you have to go off your paper. In this problem, I chose 1 centimeter as 5 meters. That means the first vector that's listed, the 25 meter vector, will be 5 centimeters long. The second vector listed, the 18 meter vector, will be 3.6 centimeters long. Now what I do is go ahead and start to draw my vectors. I place my ruler in the direction of north-south so that I can draw my first vector 5 centimeters long in the southern direction. That vector will represent the first direction that was given in the problem. Now what I want to do is draw my second vector. Well, I'm going to draw my second vector from the tip of the vector that I just drew. I'm going to draw it from this point right here. And I need to make it go in the right direction, which is 45 degrees southeast. One thing I'm going to do is draw another compass rose down here. In this case, I could simply just put my original compass rose at that point and then realize that I'm going to draw that vector some way in this direction to represent 45 degrees south of east. When I say south of east right here, I basically am saying that I'm going to take 45 degrees in the south direction as measured from east. That's what this means. So I'm going to take my protractor and bring it here. I'm going to spin it around so that I can measure a 45 degree angle from here down to this point. That's where 45 degrees is. If I was like you and I had a protractor, I would make a little tick mark down here where 45 degrees is going to be, and then I'll bring my ruler down to measure that. Bring my ruler in, and I'll rotate it to that direction, and then I'm going to draw a vector that is 3.6 centimeters long to represent that movement. I'm going to move my compass rose out of the way so as not to confuse the problem. And now I have my two vectors drawn together tip to tail. The resultant of this motion is basically the vector that goes from the beginning of the first vector to the end of the second vector, or from the tip of from the tail of the first vector to the tip of the second vector. This red dotted line represents the resultant. The answer will be the length of this red dotted line and what direction it goes in. To measure the length, I'm just going to take my ruler and I'm going to move it to this position so I can see how long it is. I can see it's about 8.1 centimeters long. With my scale, that means it's going to be 8.1 times 5, which is 40.5, I believe. So now what I want to do is measure the direction that that vector points. To do that, I go back up to the beginning of my resultant vector, and I use my protractor to measure that angle. Now in this case, I could really measure from east-west if I wanted to, or I could measure it from south if I wanted to. It makes the most sense to measure from south here because I can put my protractor along the south vector that was already there, and I can see what this angle is. It looks like it's about 20 degrees east of south. So that's the vector that I'm going to label. Like so. Now I just have to report this final answer in a way that makes sense. The resultant displacement in this problem is 40.5 meters, 20 degrees east of south.